Hello everyone, welcome to lesson 622, day 2. Today's goals, we're going to be solving exponential and log equations. This is meant mostly as a review, just to make sure we see it one more time before the quiz tomorrow. But we're really going to be focusing on this addition and subtraction property to expand and condense logs. All right, so we're gonna see some examples of those, and we also want to focus on rewriting log and exponential expressions. Whether that means going from exponential form to log form or log form to exponential form, or using power property, addition property, and subtraction property to write equivalent statements. All right, so we're really focusing on 2 and 3 today. All right, so we're gonna jump right into it here. We are rewriting the following expressions down here as exponents. So remember, logs are exponents in disguise. So we can rewrite this as an exponent simply by using the circle of life, right? So we're going to start with the base here, which is 9. And then we're going to circle around to the other side of the equal sign, right? That gets us our exponent, which is -2. So we're saying 9 to the -2nd must equal. And what it must equal, we circle back around to what's inside of the logarithm. That is x plus 9. So that entire expression is what 9 to the -2nd must be equal to. So it's got to be equal to x plus 9. So now this equation that I wrote here is equivalent to this equation that we started with. Okay, so let's try it again. This time we have a base of p, so I'm going to start with my base. We circle around to get our exponent, so that's going to be p to the x power must equal whatever is inside of the log, which is 9/5. Okay. And if you get a fraction like that, just leave it as a fraction. There's no need to solve here. So we're just rearranging the pieces going from log form to exponential form. Now let's go the other direction. These are exponentials, and we want to write them as logs. All right, so we're going the other direction. Now remember, log has 3 parts. So I'm going to say log, base, input, output. Blank for the output. There we go. Okay, so I look at the expression, I find my base, that's 9. It's being raised to the x plus 4 power. So that entire expression, the x plus 4, that's all in the exponent there. So remember, the exponent goes over here, right? If we were circling around, this is where we would find the exponent. So I'm going to put an x plus 4 here, and that's got to be equal to whatever's inside of the log. So 9 to the x plus 4 is equal to 61. So I'm going to put that into my parentheses. So that completes my log expression. I'm going to do it one more time over here. So same thing, the base is 6. Let me set up my log here. So I've got log, base, input, output. All right, base is 6. We're raising to the first power, and it's got to be equal to x. All right, so again, just using that circle of life to help me place the pieces in the correct position. All right, let's keep going. All right, so notice I'm trying to bold and underline the important words in the instructions because it's going to be the same thing on the quiz, right? You don't want to miss something if it says rewrite, condense, expand. So make sure you're paying attention to those words. It kind of triggers, what you're supposed to do. It'll jog your memory, right? Certain words. So this is condensing, and when we condense, we're starting with a log expression that has multiple logs in it, and we're trying to condense it to a single logarithm. And one of the properties that we learned about yesterday was the product property or the addition property. So here I see addition between 2 logs that have the same base. So this is an opportunity for the product property to condense this expression, okay? I also see these numbers out front here, right? So the 4 here is a power property, right? And so is this 5. You saw me do this in the video yesterday. I just like to scan and think about which properties I can apply to this thing before I start actually applying any properties. So when I'm condensing, I like to do the power property first. All right, so I want to put this 4 back as an exponent on the b. So I'm going to rewrite this as log base 4 of b to the 4th. Okay, so I put the 4 back. Plus, and then I'm going to take this 5 and put it back. So I'm going to have log base 4 of y to the 5th. Okay. Then I'm going to take care of the product property. And remember, the product property says if I have two logs of the same base being added together, I can condense it into a single log by multiplying the inputs. So I can say log base 4 of, and I'm going to write a single log here. But to get my single log, I have to multiply the two inputs here. So I'm going to have b to the 4th power times y to the 5th power. And that all goes inside of the single log. So if I were to evaluate this expression and evaluate this expression, I would get the same value. They are equivalent. Okay? So remember, when you're condensing, power property first, then product property, in that order. All right? Let's try it again. We're going to do this same kind of problem here. So again, I see numbers out front. Right? Those are powers. Okay? And then I see a plus in between the two logs, so this is going to be a product property again. And remember, we want to go powers first, then product. So I'm going to put the powers back. So I've got log base 5 of x to the 6th power. Right? That 6 just goes right back up here as an exponent. 4 is going to do the same thing. So we got plus log base 5 of b to the 4th. Just like that. Okay? Now I'm going to handle the product property. That's the addition here. So I can condense this down into a single log. It's got to have the same base of 5. And I got to multiply the inputs, right? X to the 6th and b to the 4th. So I'm going to say x to the 6th times b to the 4th. And that completes my expression. So now it is a single logarithm that is equivalent to the original expression. All right. One more over here. So I'm just kind of scanning. I'm scanning my thing here. And you notice here this _7, that's supposed to be a base 7. So this is a base of 7. This one has a base of 4. So that is an issue, right? Because for the product property to work, the bases have to be the same. Right? So these were both base 5. So that was okay. And over here, they were both base 4. But this one is base 4. This one is base 7. And so I can't use the product property here. Right? The only thing I can do is I can put these powers back. Okay, so these powers that are out front, I can put the 4 back on the A, I can put the 3 back on the Y. So I could say log base 4 of y to the 3rd plus log base 7 of a to the 4th. And that's really all I can do there. Because they have different bases, I can't apply the product property. All right. Let's go the other direction. Let's expand a little bit. Right? So now we're trying to blow the log up. We're trying to go from a single logarithm to a lot of logarithms, just like this. Okay. So again, I like to scan my expression real quick and look at what's going on. So inside of the log here, these two things are being multiplied. Okay, so there's a multiplication there. They don't usually put the dot there to represent the multiplication, but when two things are right next to each other in math, we typically assume that they are being multiplied. All right, so that is a product property. And then we also see powers. Okay, now since we're going the other direction, we're going to do the product property first and then the powers. So it's backwards from what we were doing with the condensing. So I'm going to split this log up. And since the original log had a base 7, when I split this up, both logs are going to have a base of 7. Okay, so I'm going to split this up, and the first thing is the x to the 6th, so that'll go in my first log. And then I'm going to have a second log, also with a base of 7, and it's going to have the second factor in there, which is z to the 11th power. And since it's a product property, I'm going to add these two logs. Okay. Now I'm going to apply the power property, which is where I'm going to take this power and I'm going to move it out front. Same thing with this one. This one's got a power of 11. That 11 is going to move out front. Okay, so I'm going to say 6 log base 7 of x plus 11 log base 7 of z. And there we go. That is fully expanded. All right, let's try it again. All right, so again, I got a log. I'm seeing exponents. Okay, so these are powers. I see powers. And then the other thing I'm noticing here is this bar, which means division, right? So this is a quotient. This is a quotient property, right? They're not being multiplied, they're being divided, which is, and that's quotient is a fancy word for a division, okay? So we're going to be applying the quotient property here. And again, since we're expanding, we're going to do the quotient property first and then take care of the powers last. All right, so I'm going to blow this log up. I'm going to say log. The base was 6, so it's got to stay at base 6. My first log. I'm going to put the thing in the top, right, the numerator, so that's going to be x to the third. And then in my second log, it's also got to be a base of 6, and I'm going to put the denominator in there. So I've got y to the fifth in this one. And since it's a quotient property, instead of adding here, I'm going to subtract. Okay, so quotient, subtract, product, add. All right, now I'm going to take care of the powers, right? So I want to move this 3 out front. And I want to move this 5 out front. Okay, so I've got 3 log base 6 of x minus 5. Almost, I was writing 4. I want 5 log base 6 of y. And there's my fully expanded expression. All right, so hopefully that helps you out. Those are you got some good examples going on there. If you have any questions, make sure you're asking them. Okay. All right, so to wrap this up, we're going to work on just a little bit of solving. These are brand new types of equations that you've never seen before until this unit. So I just want to make sure I hit these one more time before we get to the quiz tomorrow. So if you are solid with these, if you know how to solve these already, you can go ahead and skip this part of the video, but if you want to see a couple more examples, you should continue watching. All right. So my goal is to solve, right? And when we solve, that means we're trying to find a value of x that's going to make this thing be true. So to do that, our goal is to get x by itself. All right. So I'm going to start by adding 6. And I know this looks a little confusing. This x minus 3 is an exponent, right? So that whole expression is an exponent or a power. Right, and this minus 6 is not in the power. It might be a little difficult to tell with the formatting, right? But this is not in the power. The x minus 3 is. So that means I can take this 6 and I can just move it over to the other side right now. So I'm going to add 6 to both sides. So I've got 4 to the x minus 3 equals 19. Okay, so this is what we call isolating. I'm trying to isolate the exponent by itself, so I have the exponential part on one side and a number on the other side. Okay, so right now we are isolated, and at this stage what I'm going to do is I'm going to take a log of both sides. So I'm going to say log, and I'm going to put the left-hand side in this log. So I'm going to say 4 to the x minus 3 equals, and since I took a log over here, I have to do the same thing on the other side. So I'm going to say log of 19. Now I'm using a common log, so that's a base 10. That's why I didn't write the power or the base down here. Okay, you can choose whatever base you want to use for your log on this step. You can use a natural log, a common log. You can use base 2, 3, 4, 5, whatever you want. It does not matter what base you choose here, as long as they are the same on both sides. Okay, so now I'm going to use that power property. I'm going to take this x minus 3 and I'm going to put it out front using the power property. So I've got x minus 3, and I'm going to put that in a pair of parentheses just to keep it together, times the log of 4. Right? The 4 no longer has the x minus 3 on it. It moved out front using that power property. Now over here we've got log of 19. Okay. And then what I'm going to do, since these two things are multiplying, I'm going to divide. And I'm going to divide by log 4. And whatever I do on one side, I've got to do on the other side. Okay? So log 4s are going to cancel out. That was the whole point of dividing. Okay? So now all that's left is x minus 3 equals log of 19 over the log of 4. And all I have to do now to get x by itself is add 3 to both sides. Okay? The 3's will cancel. We've got x equals log 19 over log 4 plus 3. You just tack that plus 3 right on the end. Okay? And then this is what we would call the exact answer. This is exact. All right? We just leave our answer like this. This is good enough for an exact answer. However, if they ask you to approximate your answer, this is where we need to get the calculator out. Okay? So I'm going to approximate my answer to 3 decimal places. Okay, and I'm going to put log 19 divided by log 4. So I'm just going to hit log 19. And you see that button's nice and handy. It's right there. So that's why I choose the common log most of the time, because I've got a nice, easy to use button on the calculator. I don't have to go to the math menu to get my logs. So, right, so I got a log of 4 in the bottom. And then I'm going to add 3. So I got 5.124. All right, now just a quick note on the rounding here. So if we wanted to round to 3 decimal places, I go to the 3rd decimal place, then I look at the next number, and you can see that's a 9. Okay, so since that's bigger than 5, this number 3 is going to go up to 4. All right, so just a quick review there on rounding. Okay, so x is approximately 5.124. X is exactly log 19 over log 4 plus 3. All right, so you're going to need both of those answers for your quiz tomorrow. Okay, let's do one more. This one is a log equation. This one was an exponential equation because it was written in exponential form. This one is a log equation because it's written in log form. We can solve either one. Okay, so first I'm going to isolate. I want to get this by itself. I want everything else to move, right? I just want the log all by itself on one side. So this plus 2 needs to go. So I'm going to subtract 2 on both sides. So I've got 3 times the log base 2 of x. These 2's are going to cancel, and I'm going to get 14 on the right-hand side. Okay, now I want to get rid of this 3. It's multiplying, so I'm going to have to divide. So 3's cancel. Now we've got log base 2 of x equals 14 over 3. Don't turn this into a decimal. Just leave it alone. Leave it as a fraction. All right? Fractions are okay. They are your friends. All right, so here we go. So now I have my log expression isolated. And to get x by itself, I'm going to have to use my circle of life. I'm going to have to rewrite this as an exponent. So I'm going to start with my base, which is 2. I'm going to raise to this power. I know it's going to be weird, but we're just going to put 14 over 3 in the exponent. Right? So 2 to the 14 over 3 power equals x. So just by using the circle of life and rewriting in log or in exponential form, I got x by itself. And this is our exact answer. Now I need to get my approximation, so I'm going to approximate to 3 decimal places. So I'm going to take this and put it into the calculator. So I'm going to say 2 raised to the 14 over 3, right? And you notice in your calculator, it puts it all in the exponent for you. That's what you want. Then hit enter. So we got 25.398. I'm looking at the next number. It's a 4, so it's going to stay an 8. So 25.398. And there we go. This is approximate. Okay. Like I said, you'll need both of those for my open math. All right, guys, have a great day. I hope you found this helpful. Let me know if you got questions.